Welcome to AI Podcast. I'm Daniel, and today we're unpacking an ACL 2025 industry track paper titled Generating OpenAPI Specifications from Online API Documentation with Large Language Models, led by Koren Lazar and colleagues at IBM Research.
Hi, Daniel. I skimmed the abstract, but I'd love the quick take. What's the bottom line here?
In short, the team shows you can turn messy, human-oriented API web docs into clean, machine-readable OpenAPI specs by using a staged pipeline with light scraping and in-context prompting. Instead of one giant prompt, they split the task into smaller steps, merge the pieces, and then do a targeted polish pass. It works much better than trying to generate a full spec in a single shot.
So the goal is to make APIs LLM-ready without waiting for providers to publish official specs. That makes sense.
Exactly. Many APIs still present only HTML meant for humans. Agents and developer tools need OpenAPI to reason about endpoints, parameters, and schemas. This paper tackles that gap directly.
Before we get into the method, who's behind the work?
The paper is led by Koren Lazar at IBM Research, with a broader IBM team. It's a very applied, industry-focused project.
All right, what makes this problem hard in the first place?
Three main reasons. First, documentation layouts vary a lot. Expandable code blocks, parameter tables, narrative text, and sometimes content is generated by JavaScript. Second, the pages can be long, and a single prompt struggles to hold structure while staying accurate. Third, earlier approaches tended to rely either on brittle rules or on unstructured LLM generations, and both have failure modes.
When you say earlier approaches, you mean things like scraping rules or observing live traffic?
Right. Inferring specs from traffic or source code can be precise, but it requires access to the system. HTML to spec systems with handcrafted rules break when the layout changes. And simply feeding a long page to a big model runs into context limits and structural drift. The gap is clear. We need something that generalizes across layouts and long pages while staying grounded.
So what's the core idea they test?
They treat docs as two complementary views. The demonstrative view is usage examples, like curl requests and sample JSON. The descriptive view is the parameter tables and narrative text. They process each view with prompts tailored to that evidence, then merge the results into one OpenAPI spec.
I like that. Examples capture structure, descriptions capture meaning and constraints.
Exactly. The pipeline starts with a light scraping and segmentation step to expand accordions, reveal code examples, and group evidence for each operation. For the demonstrative view, they canonicalize requests and ask the model for partial OpenAPI, paths, methods, parameters, and candidate JSON schemas drawn from examples. For the descriptive view, they isolate the parts of HTML that look like parameter definitions or field tables and prompt the model to produce attributes like descriptions, required flags, enums, and defaults.
And then they merge those two outputs, right?
Yes. They define precedence rules. If an example clearly shows where a parameter lives, say query or path, that comes from the demonstrative side. If the docs specify what the parameter means, or whether it's required, that comes from the descriptive side. After merging, a focused enhancement pass fills obvious gaps. Short descriptions, example values, or enumerations. Only when certain cues are present, which avoids unnecessary model calls. Finally, there's a simple review interface for a human to spot check and fix edge cases.
That only when needed enhancement sounds practical. It keeps the system from over-editing and wasting calls.
Exactly. It's a pragmatic choice to keep cost and drift in check.
How did they evaluate all this, especially without a public benchmark?
They run 3 evaluations. First, a syntactic check over documentation pages and operations to see if outputs are valid JSON and valid OpenAPI, and to count schema validation issues. Second, a semantic check on a labeled subset where they compare discovered parameters. attributes like required or default, and descriptions against ground truth. Third, a scalability sweep across a larger set of documentation URLs to see if the pipeline holds up as you crawl more sites. They also swap in different instruction-tuned and code-tuned models with the same prompts. In general, code-oriented models produce cleaner, more valid specs.
What stood out in the results without drowning us in numbers?
Two things. One, the staged pipeline yields a high share of valid OpenAPI outputs across diverse sites, which is non-trivial. Two, on the semantic side, it consistently captures most request-side information, endpoints, and parameters with strong precision. Descriptions and flags like required or enum are filled reasonably well from the descriptive view. The weaker spot is complex response schemas, where very deep or lengthy JSON is harder to reconstruct perfectly from partial examples and text.
That tracks with my experience. Docs often show trimmed responses and the gnarly parts get skipped.
Exactly. The paper also contrasts this with a single-pass attempt. Dumping a raw page into a large context model and asking for a full spec tends to fail on long docs or drift structurally. The split and compose approach is the key to reliability here.
What assumptions should listeners keep in mind?
They assume evidence for an operation appears near each other on the page, so segmentation works. They assume models have seen OpenAPI structure during pre-training, so a few in-context examples suffice. And they assume the docs provide either runnable examples or descriptive tables. Narrative-only pages or very unconventional layouts are still awkward.
Any other limitations we should flag?
Two big ones. There isn't yet a widely adopted public benchmark for this exact task, so cross-paper comparisons are limited, and not every OpenAPI facet is fully covered out of the box. Authentication schemes, rate limit headers, error models, or webhooks may still need human polish after the pipeline runs.
That's a useful heads-up for anyone planning a production rollout. Start with endpoints and requests, then refine auth and error handling.
Exactly. Use the pipeline to jumpstart a spec, then apply targeted editorial passes for security, pagination conventions, and error shapes.
Why does this matter beyond convenience?
Two reasons. Robust OpenAPI unlocks agents and tooling, from automated testing to safe tool use for LLMs. And in enterprises, internal APIs are often documented in wikis without formal specs. A reliable conversion path lowers the barrier to automation without rewriting everything by hand.
If you had to distill the contribution into one practical lesson, what would it be?
Treat API docs as two sources of truth, examples and descriptions. Design prompts and checks that respect each, then merge with explicit rules and finish with a light enhancement pass. That's the recipe.
And what should the community tackle next?
First, a public, diverse benchmark so methods can be compared fairly. Second, better handling of complex response schemas, maybe with layout-aware parsing. Third, broader coverage of OpenAPI features like auth schemes, server variables, callbacks, and error models. Fourth, user studies that measure editing time saved and downstream gains for agents. And finally, expansion beyond REST HTML toward OpenAPI 3.1 nuances, GraphQL, or async API.
Sounds like there's plenty of room to grow, but the foundation is solid.
That's my read. For teams drowning in HTML docs, this staged approach is a credible path to high-quality specs with manageable human review.
If you want to read the paper, search for the title Generating OpenAPI Specifications from Online API Documentation with Large Language Models by Koren Lazar and colleagues at IBM Research, ACL 2025 Industry Track.
You've been listening to AI Podcast. I'm Daniel.
And I'm Maya. Thanks for joining us.